Hey Maddie, I think I might have found a possible solution to the question you asked me earlier today about how to calculate the mean fluorescence intensity when you have a ring-like structure. So let's just open up the image in ImageJ that I saved from earlier, and I'll zoom in here. And let's just see what I get first off, looking at this big cell if I just trace it with the freehand tool. Um, like you said, the mean gray value is really low, so I'm going to measure it. And so we get a mean gray value of 3.901, which is indeed really low, and that's because the center is obviously bringing down the mean. So I found a way that we could calculate just the ring. It's not super clean though. It's kind of it's a workaround, but it's not super reliable because you have to draw everything by yourself. But anyways, if you draw this circle around your cell and then you hit, if you hit T, it'll add this thing to your ROI manager. So let me do that again. So if I draw something here, now I'm going to hit T and your ROI manager is going to come up. And then this will allow you to measure multiple regions of interest. I think I probably showed you this before. And I like to hit show all, and that way I can see the regions of interest I drew before. And now I can draw a region of interest on the inside, which is just touching the ring. So obviously this can't be super accurate because, I mean, it's going to be kind of subjective which part of the ring you're going to include. And then you hit T again, and that'll add both of these regions into the ROI manager. And then I'm going to go to Analyze, Set Measurements. And right now I'm looking at the area, integrated density, and the mean gray value. These are the three I'm going to want to have selected in order to calculate the mean gray area of just the mean gray value of just the ring. And then we're going to go to more, multi-measure. And then normally I think this is going to be selected one row per slice, but I don't think we want that here, so just unselect that. And you are going to get these results. This might happen if you just have one of these selected, so make sure you have both of these, everything unselected. So I hit deselect and then multi-measure. And here we have, so this is the data from the first one, and here's the data from the second one. So I'm going to copy this into an Excel sheet. Okay, so this first one is area, this one is mean, this one is integrated density. Okay, so these are what you're going to use in order to calculate this. So the mean gray value is equal to the integrated density. Integrated density is just the total fluorescence, basically. So mean gray value is the integrated density divided by area. And also, obviously, area times mean gray value is your integrated density. So using this, we can actually calculate the mean gray value for just the ring. So first, I'm going to do equal sign, and then take our first area of the outer ring and subtract it from the inner ring. So now we have the new area of the ring. So this is new area. And I'm also going to want to subtract the integrated density of the entire ring minus the integrated density of the inner ring, because we don't want to include extra density that was not in just the ring area itself. Okay, so equals um, this one minus this one. So ring int density. Okay, so you have something like that. And now if I want to calculate the mean gray value, it's just really simple. I just have to do integrated density divided by area. So this is mean value, mean of ring. So equals this one divided by this one. And you're going to see it's going to give us a value of 10.0733, which is much higher than our original measurement of 3.916. So now we're kind of eliminating that empty space, bringing down the mean. Okay, so we can continue applying this to the rest of the image stack. So for example, this one, I can trace these. So I'm just going to trace a couple more and just show you how it's going to look like once you have several cells. So obviously it's going to take a little more time probably. I don't know if you need to continue doing the thresholding, but hopefully this is a suitable workaround. I'm not sure if there's any plugins to do this. If there are, that would be probably the best because, like I said, it's kind of subjective doing this. And also you want to make sure you always stay in the same order, otherwise it's going to mess up your Excel sheet later and cause you problems. So you always want to draw the outer circle first and then draw the inner circle. Um, so maybe this guy right here. See, like this one's pretty subjective because I can't really clearly see where the ring is ending and beginning. But yeah, just wanted to show you this just in case this might be a good way for you um, to do this calculation. Okay, so now we have four of these things drawn. So I'm going to go to more, multi-measure, and then do the same thing. And then the results should pop up. I'm going to copy paste this over to the Excel sheet. So again, these are area, mean, integrated density. First, I'm going to subtract and find the area of the ring. And then I'm going to subtract the integrated density. So we have just the integrated density of the ring. And then what you can do is just really convenient. You can just copy paste these into each of the same location. So like you don't want to copy paste it here because this is going to be calculating something different. You needed to calculate it like every one square apart, one cell apart, if that makes sense. Okay, and then we can just do the same thing. This divided by this. So this one has a mean of 10.7. This one's about 18. This one's about 8. And this one's about 11. And you can see these are all much higher than they were originally. So originally the mean for the first one we looked at was 3.9, and this one was 14, it went to 18. This was 6, and it went to 8, and this one was 5.5, and it went to 11. So hopefully this is useful, and let me know if this will work for you. There's probably some other ways to calculate this, but if this works, that would be great. So yeah, hope this is useful.